We will see the demo for the analysis of a 2D truss, and then we will see that how the 2D truss is designed. So let us do first the analysis of 2D truss. This is the program where you can draw the truss and give the input data and do the analysis. Okay, so first of all you have to fix the scale factor before giving an input if required, and you can use these coordinates to draw the frame. Okay, truss, draw the truss, right? And if it is a flat slab with circular columns or non-rectangular columns, then you can draw the frame with the help of this command, as we have seen in 2D frame analysis. Okay, so we will give the data through this coordinates and draw a truss. Say we have a vertical member first like this, x is 0, and please press enter key after to save the data in the text box. So press enter. y1 is 0, press enter. X2 is 0, press enter, and y2 is 4 meters. Say the height of the member, length of the member is 4 meters. Okay, so press enter and draw member. So this is how the member is drawn. Now let us draw another member which is of length 4 meters. Okay, so x1 is 0, y1 is 0, x2 is 4 meters, y2 is 0. So this is the member you draw. Okay, now let us draw another member which is like this over here. So x1 is 0, y1 is 4 meters, x2 is 4 meters, y2 is again 4 meters, right? You can draw the member. We can draw a vertical member over here where x1 is 4 meters, y1 is 0 meters, x2 is again 4 meters, y2 is 4 meters. You can draw the member. Right? Now we have a diagonal member like this. So let's draw this member. x1 is 0, y1 is 0, x2 is 4, y2 is 4. Okay, now let's just draw a member like this, another diagonal member. Okay, so x1 is 0, y1 is 4, and x2 is 4, and y2 is 0, right? So this is how a truss is drawn. Now this page shows that how do we have to number the text box. These two are the frame joints, these two are the support joints. We can see that all the frame joints have to be numbered first, support joints have to be numbered at last. So let us give the number to the text box. Drawing is complete? No. Okay, so this is 1, this is 2, this is 3, and this is 4. Now let's click finish, exit. Frame is complete, drawing is complete. Yes. Have you filled the text box? Yes. Okay, write the number of frame joints. 2, right? 2, press enter. Write the number of support joints. 2. Okay, right, enter. Right, now support 3 is hinge. Okay, now support 4 is hinge. Okay, now we see that the text has changed to green color because it is hinge support, right? Now we can give the load data to the frame, okay, by using these two commands. Okay, when the member in the truss is less than 3, then you have to use manual command. But as the member are more, so let us use this command, right? Okay, by mouse. Okay, as this is a truss, so width and depth are not to be given. It will be taken care of later. Just give a point load. Okay, now see, we have an axial load. Okay, this is the member, and we want to give a axial load over here, right? And the axial load is acting at this point. This is the initial point, this is terminal point, and the load acting is over here and in the direction of the initial point. So let us take the point axial load point P3, that is pointing towards IP. Say the magnitude of the load is 25 kilonewton and it is at a distance 4 meters. This is IP. You have to give the distance from IP. So if the load is acting at this point, at this joint, axial to this member, then this distance is 4 meters. So let us give 4 meters, right? Now just click this member. This is your initial point. This is your terminal point. Select this member. You can see the load. Okay. So this is point load acting, right? Now let us assign the load, right? Okay, now. So this is one load which is acting. Now we can save the file. Okay, give the data. Save it as M. Okay, right. Now run analysis. So the first point is we have to select the which kind of section is it. Okay. Now let us say all the members in the bar, all the members in the truss are bars, solid bars. Okay, or we can say they are T. Okay, so the condition for T is 4. Okay, the total number of members in the truss are 6, right? So let us press enter. Okay, so for member number 1, the condition we are taking as a T, that is 4, right? And say we are taking the section as the flange width. This is the flange width, right? Say the flange width is 150 mm. Okay, press enter. Okay, always use enter key. Whatever value you give in the text box, then you have to press enter key to save the data. Okay, now width of flange. Now what is the width of flange? Depth of flange. This is depth of flange. Okay, so we change this to say 6 mm. Okay, 6 mm. And width of flange, this is width of flange, so it is 150 mm. Press enter. Depth of web, this is depth of web, so this is 150 by 150 angle, 75 by 150 angle. Okay, so 150 is the total depth minus 6 mm, so that will be equal to 144, right? Press enter. Now the width of web. Okay, this is width of web, that is again 6 mm, right? Now we assume that all the 6 members are of the same condition or same section. Okay, so simply click this command, repeat, write the data, the number of the member whose data is to be repeated, say 1, press enter. Okay, just press enter at every text box so the values are saved. Okay, now give the member data for member number 3, say it is the same as member number 2, just press enter. Again press enter for each text box. Okay, again we assume that member number 4 is identical to member number 1. Okay, so press enter. Again press enter key to save the values. Again, now member number 5 is similar to member number 3. Enter. Okay, press enter, and last member is also identical to say member number 2. All the members are same, so you can write any member number, all the members are identical. Okay, so just press enter. Okay, so this is how the data have been given. So click finish, right? Yes. Okay, you can see the output. So this shows the distance of CG from top left, mi about x, moment of inertia about x-axis, moment of inertia about y-axis for this, and we have selected a symmetrical T section. So this is how this page shows the uh, details of CG and mi for each members in the truss, right? Okay. Now you can run input. Okay. And you can run analysis. Write the modulus of elasticity in kilometer per meter square of the material. So it is say 2E8. Press enter, and the lateral loads are say 1, 1. Sorry, load factors are 1 and 1. Finish the command. Finish. You can see the output, right? So this is the design, right? Okay, you can see, let us take member number 3. Member number 3, axial force is 2.88. Axial force, if it is in tension, this is positive, and clockwise moment is positive, right? And the corresponding moment are very zero, okay, very almost zero. This is a moment at joint 1, this is joint 1, and this is the moment at joint 2, this is joint 2. Okay, we are considering this as welded joints, so but the moments are almost zero because the cross-section area is very small as compared to the length of the member. Okay, so after doing the analysis, you can go to design section. Okay, there you can just click this button, which will do the design of the truss, right? Okay, you can see the output. So we can see that all the sections which we have selected are found to be okay, right? So this gives detail. Okay, so this is how the truss can be designed. Okay, and this checks that whether the section which we assume are found to be okay or they fail. If they fail, then you can always change. Okay, you can always change the section, right? For that, you can again reopen that file over here, okay, from existing file, right? And you can edit data. Do you want to change any load? It is asking. Do you want to edit any data or load in any particular member? If you want to select it in serial, then you select this command. If you want to edit some particular data for a particular member, then you select this command. We don't want to edit any member data, just say no, 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 and resave the file. Okay, okay, yes. Now, is this a truss or flat slab file? Yes. Now click run analysis for 2D truss flat slab. So let us run this, and you can always open, right? If any of the section fails, okay, then you can change the cross-sectional area. Okay, you cannot change the type of section, but you can always change the cross-sectional area. Say you want to change the cross-sectional area for member number 1, just edit data, write member number 1. Okay, you can change anything if you want over here. Say if I change this to say 145, right? And then I just have to press enter key at every text box Okay, see it now for at present it is 144. Now when I press enter key, then this will be edited and you will see the value is 145 over here, right? So press enter, 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 enter. Okay, so the section has been changed, right? Now after editing the required section, you can exit. Okay, now okay, and now you can see uh, this is the CG and MI for the revised section, right? Now you again have to run input. Okay, now do run analysis. Say the modulus of elasticity is a 2e8. Press enter, and load factors are 1 1. Okay, click finish. Okay, and you can see the output. So this is the output with the new revised section which you change, edited. Okay, then again you can go to program list and just click this. Okay, and you can see the output. So our sections were already found, all right, but if some of the section had found to be failed, then by changing the section and again running the design, 2D design, 2D frame design, sorry, 2D truss design, you can again cross check the answers, and by assuming a particular correct section, you will get all sections to be clear, that is to be found. Okay, okay, so this is how you can do the analysis of a 2D truss and also do the design of the 2D truss using MMS programs. Thank you.